Okay, so as we mentioned, depending on the situation we have, we can calculate, let's say, the COP of heat pump or the COP of refrigeration. We can try to deduce graphically how we can enhance the efficiency. You know that in general, you might try to, and as we mentioned, for example, before, in case of power cycles, we said that it's advised to have as much as possible a high quality at the exit of the turbine, okay, because this will first enhance the efficiency of the system. In addition, it will reduce damage to the turbine. We can do similar analysis here. So in this case, in our problem, if we can go condense more, and the lower the temperature at the exit of the condenser, we'll be able then to enter the evaporator with a lower quality. So here it's suggested that we should try to enter the evaporator with a lower quality as much as possible to have a wider zone here where we can extract heat from. Okay. And as we said, for the compressor, we avoid to enter the compressor as a mixture. We should at least reach the saturated vapor, or we can reach also superheated, because this will be good, because this will increase the value of Q extracted from the refrigerator. Okay, since in order to increase Q dot N, which is equal to the difference between H1 minus H4. It's desired as much as possible to start, if you want. Of course, we should pay attention that what count at the end is the ratio. Okay, and you have the COP was Q dot N, which is H1 minus H4, over H2 minus H1. So also, okay, increasing a lot the value of H1 will not be good, because if you do a lot of superheating here, and if you exit your evaporator at a high value of H, you will reduce also. This will reduce for you maybe the value of possible power within your compressor. So you should optimize the ratio here. This is why whenever we want to do the design, okay, we tried several configurations to determine what is the optimal case to do. So what is the best point at which we should leave the evaporator in order to enter the compressor in order to get the best efficiency. And the majority of systems will require optimization techniques in order to select the optimal point at which to exit the evaporator and enter the compressor. Okay. Similarly here, we said that it's good to reduce the value as much as possible to try to reduce the quality, because if we reduce the quality here, so this point was 4. Okay, if we try to reduce the quality of 4, this will be good, because this will not affect, if you want, the value of the inlet. H1 will not be affected, so you will keep enough high value for your W. Okay, and then you will be able to. This will not affect the efficiency in a bad way. Okay, so you will be able to increase the inlet, the extracted heat, while not increasing at the same time the W dot required for the compressor. Okay. Any other question on this? Okay. So in overall, this can be a sample problem for the exam. If you have any question concerning the exam material, or if you need any help, let me know.
Okay, thank you, Professor.
Welcome.
Thank you.
Bye-bye.
Doctor,
Yes?
concerning the midterm,
Yes.
it will be on campus, right?
Yes, sure.
Okay,
It is
during
on
the time
campus
of the session.
during the time of the class, yes.
Okay, and will it be like multiple choice and with
Yes,
problems?
you have a part that is multiple choice. In this part, you just have to read the slides and understand well the content for this part. And you will have problems. You will have problems on heat transfer. You will have problems on cycles. Okay. You should understand the operation of cycles. And the question might be qualitative or quantitative. And I might just tell you, for example, describe the cycle, why do we use it, how we can enhance its efficiency. Okay, or I can give you, let's say, a problem on refrigeration, on Rankine, any of the applications we tackled together. You should understand how the cycle operates and how to calculate the enthalpy at different points. Okay, and then plus we can also have, let's say, a problem on heat transfer. So a problem involving generation, conduction, convection, radiation. We should know how to write the energy balance and how we can solve for, let's say, steady and unsteady cases, etc. Yes,
Okay,
yes,
Professor,
Muhammad, yes.
problems like those, like the one we did, like the cycle, to draw the TS diagram.
Yeah,
إنه معقول يجوا؟
yes, sure.
Okay. Okay. Thank you.
And I can give you a description of a problem. Okay.
Okay.
And for example, refrigeration is not included in the slides. Okay.
Okay.
As the concept of refrigeration is very close to what you already did. Just we are
Yeah.
reversing the operation. Well, I understand maybe that if I just give you a refrigeration cycle, you'll not be able to draw it on your own. But if I give you a small description, I give you some hints, I tell you that in refrigeration cycles, we extract heat from cool temperature and reject heat into into higher temperatures, and we provide work through a compressor. By just giving you this, you'll be able to draw the TS diagram. And then how to work with enthalpies, it's the main,
Yeah.
it's the same method, you use the same tables, etc.
Okay. Okay. Thank you.
Doctor, can you bring
Yes.
with us the formula sheet?
Look, I will, in case you have any empirical relation, just you should know the basic formulas. Okay, of
So we
course,
can.
in the course material you have seen, we considered several problems. Let's say when we considered, for example, the case of painting, and we have epsilon that is variable with the temperature. Of course, I will not ask you to know this. Okay, any
Okay.
empirical relations that you need in the problem will be given to you, but the basic equations you should know them. For example, the conduction formula, convection, radiation. This is what the Boltzmann constant, for example. I don't want you to remember it. I can give it for you. And such things that will require hard work to remember, I will give them. But basic concepts, like the efficiency, how to calculate, let's say, Q in, Q out, how to deal with cycles, how to do the energy balance and heat transfer. You should know all of these.
Okay, thank you.
And for cycles, if I tell you, for example, describe the regenerative Rankine cycle, you should know it. If I ask you to describe the Rankine with reheat, what are the advantages, disadvantages? And you should know why we use these modifications in order to enhance the efficiency of our systems.
Professor,
Yes.
can you hear me?
Yes, yes.
For these questions that you just mentioned, like the qualitative questions of how to improve efficiency.
Yeah.
These questions will be MCQ or written, or it could be both.
It could be both. Okay.
Okay.
And for example, here we studied together this cycle. I can tell you how you can try to improve the efficiency by just looking at your formula. Okay, for example, you say you can check, for example, if I increase H1, this will make maybe the work of compressor more difficult because I will have larger difference than H2 minus H1. So this might affect my case in a negative way. So I should optimize maybe the location here. So it's good maybe to increase it a little bit because this will increase the Q dot N, but at the same time, it might increase H2 a lot. So I should check for this. I should optimize this point. While point 4 is just affecting, let's say, this term Q dot N. So a good strategy will be to condense more in order to be able to decrease the quality at the inlet of the evaporator. So you can do this analysis, for example. Or in a MCQ, I can ask you, let's say, true or false. You know, I can tell you by doing reheat, we are able to enhance the efficiency, for example, because we are reducing the maximum temperature at the inlet of the turbine, or we are able to increase the QN, for example. And I will ask you and you will tell me true or false, or I give you multiple options and you select the true one.
Okay. Thank you.
Welcome. Other question? Okay. If you when you were practicing with chapter 3, you can use any thermodynamic tables, but if you want, I can send you the ones used in the problems in case you don't have them. But in general, any thermodynamic tables will work. The only difference is the reference, you know. And delta H will not change. The value of H can change, but delta H will be the same. So any thermodynamic tables will work. And I will provide you in the exam with tables. No, don't worry about them.
Could you please share the tables with us?
Yes, I will. Look, I will post a link for the book. Okay, the book where I extracted the tables, and I will post a link for you on Moodle.
Okay, thank you.
Welcome. But they are different from the tables I used now, okay? Because you know each book represents different tables. So I will post for you the ones we are using in the problems, okay? And you can use these tables for this problem also, because at the end you will get the same result exactly. Okay, good luck for the exam. And if you need any help, then you can contact me anytime. Bye-bye.
Of course. Thank you. Bye.
Welcome, bye.